So let's talk about normal distribution. So normal distribution, when we graph it, or rather when we graph kind of a data set of some sort, will look kind of like this bell curve here. Okay, and for it to be normally distributed, it needs to have a few special qualities. Okay, so we're going to go through that today. So first, we have to set up this bell curve so that we know what we're looking for to see if this is normally distributed or not. Okay, we're going to set up the bell curve and then we're going to compare the data to it. Okay, so the first thing we need is we need to put in our mean. Okay, so in standard deviation, this curve is symmetrical. And what that means is that right down the center is our mean. Okay, so that is going to be the mean of the data set that we're looking at. Okay, then we split this off into sections. Okay, we go in either direction the same amount, say here and here, and the distance between these lines is going to be one standard deviation. So in other words, if we go up one standard deviation, so the mean plus one standard deviation, or we go down, so the mean minus one standard deviation. Okay, and we do the same thing, keep it going. The next one's going to be a mean plus 2 standard deviations, or the mean minus 2 standard deviations, right? And then the same thing one more time. We want 3 of these. So mean minus 3 standard deviations, mean minus 3, or rather plus 3 on this side, standard deviations. Okay, so that's a whole bunch of standard deviations and means. It'll make more sense once we actually have numbers in there, of course. Okay, but here's the property we're actually looking for. We're looking for 3 proportions. Okay, those proportions are 68, 95, and 99.7. Okay, these are how we determine if something is normally distributed. And here's how that works. We look at the first set of standard deviations. So that would be from here to here. So everything in this range. We want that to be at least 68% of the total. Then we expand that once, and we go from these 2 standard deviations. Okay, so adding 2 standard deviations, subtracting 2 standard deviations to make kind of a wider bin here. And we want that to be at least 95% of all values in the set. Okay, and you can probably guess where this is going. We then go down to the last set of standard deviations we made here, the plus 3 standard deviations and minus 3 standard deviations, and we want this to be 99.7% of all values in a set. Okay, so if you can fit at least 68% of the values between the first range, at least 95% of the values between the second range, and at least 99.7% of values within the third range, then something is said to be normalized or normally distributed. Okay? So that's all well and good. How does that work in practice? Well, we're going to take a look at this data set here. Okay? So this data set, we will need its mean and its standard deviation. And I've already gone ahead and found those. So its mean is 65, and its standard deviation is 12. Okay, so we're going to use these to fill in our chart here. Throw that up there. Okay, so we're going to replace the numbers at the bottom here with our new values. Okay, so I'm just going to erase these just so that we have some room. We're going to be putting them back just the same way, just with numbers that we actually know. Okay, so we're starting at the center. We want the mean. So our mean is 65. And we'll go up the right-hand side first. We know that we add 1 standard deviation for each step we take. So this one was the mean. This one is going to be the mean plus the standard deviation, or 65 plus 12, which is 77. Okay. Then the next one is going to be the mean plus the standard deviation twice. But if we're filling the chart, we can just add the standard deviation again. So we end up with 89. And then we can do that again to end up with 101. Okay. So that's the mean plus 1 standard deviation, 2 standard deviations, 3 standard deviations. Okay, now we do the same thing, subtracting standard deviations to go this way. So 65 minus 12 will be 53, minus 12 again will be 41, and minus 12 again will be 29. Okay, a little bit of quick math. Okay, so now we know what these bins look like, right? We know that our first bin, our 68% bin, I'll actually do that in red so it's color-coded here, because we fancy like that. Our 68% bin is going to run from, looking at it here, 53 to 77. So that's anything between 53 and 77. That's the bin there. Then our 95% bin runs from 41 to 89. Okay, and our last bin, our 99.7% bin, runs from 29 to 101. Okay, so our job from here is to figure out how many of these values fit into each of these bins. Okay, so we are literally just counting how many fit. Okay, so we find this bin first. So we need anything bigger than 53 but smaller than 77. So we look here at these values. 51 is too small, but I have them in order here, so we know that 57 is a good amount, so we keep going until we hit something that's too big, and we get to 80. 80 is too big, so everything in here should be good. There's 8 values there, 1, 2, 3, 4, 5, 6, 7, 8. So we can say that there are 8 in that bin. Okay, same thing with the next one. We've got 41 and 89. So 51 fits, it's in between. 80 fits, it's in between. So all of them are in between. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you've got 10. And then finally, same thing with the last bin, 29 to 101. 29 is smaller than the smallest value and larger than the largest value, so it must be all of them. So that's 10. Okay, so that's how many of our terms fall within each of these bins. Now we just need to find, well, what percent is that? Well, to find a percent from a proportion, you take the number that you have, the number of terms that you have, and divide by the total number of terms. So in that case, that's going to be 8 divided by 10 equals 0.8. So that's a decimal, so if we convert that into a percent, we'll get 80%. Okay, and we can do the same thing with each of these bins, so divide by the total. In this case, that gets us 1. Then we convert it to a percent by multiplying by 100%. We get 100%, since it's all of them. And we do the same thing with our last bin here, divided by 10 equals 1 times 100% equals 100%. Okay, so now we can check. So is the first bin valid? Or in other words, are there at least 68% of all values there? Well, 80 is bigger than 68, so yes, we have at least 68% of those values. Next bin, are at least 95% of the values within this range? Well, 100% is certainly bigger than 95, so yes, there are at least 95% in that range. And the last one, 99.7% between this values. There are 100% of values in there. So yes, at least 99.7% are within that range. So we can say that this is in fact normalized. This is a normal distribution. All right, so that's how we find whether something is normal. Why do we care? What can we use this for? We don't do things in math for no reason, so there must be a use for this. So let's take a look. Okay, so with a clean graph here, we're just going to look at some of the properties here. So this is the same kind of graph. I've just removed the numbers. We've got the mean, mean plus standard, mean plus 2 standard, mean plus 3 standard, mean and minus 1 standard, mean minus 2 standard, mean minus 3 standard. Okay, so the same graph, same normal distribution, and we still know that this section should be about 68%. If it's normalized, we know that the next section should be 95%. That's 95%. And then the last section, the biggest section that we talk about, should be 99.7%. So that's 99.7. Okay. A little bit bigger, a little bit more centered for now. Okay, so those are the bins that we know. We also know that this whole thing is symmetrical. So if I were to cut it in half, if it's normal, then there should be half on this side and half on this side. And it should be according to these proportions. Okay, so that means since this whole thing is 68%, this section here is 68%, if I cut that in half, I should get half of 68%. In that case, it's 34% on both sides. So it's 34% on this side, and it's 34% on this side. Okay, well, that's helpful. We now know how much is in this particular section. Well, let's keep it going. So we also know that since this whole thing is going to be 95, well, then splitting it in half means that this should be half of 95. But we also know that half of this section is 34. Okay, so if we take half of 95, and then we take away 34 to see what's left here, we end up with 13.5. Okay, and if we use a similar process on the last sections here, we'll get 2.35. Okay, now I'm not going through every single mathematical step here because this is the kind of chart that you can absolutely look up. Okay, this is totally available to you. So what's really important is how we can use it. Okay, so let's take a look at an example here. Okay, so here's an example. Danny makes pizzas for a living. They found that the number of pepperoni slices on each pizza were normally distributed. The mean was 30, the standard deviation was 4. What percent of pizzas have more than 26 slices of pepperoni? Okay, just a made-up example, just to test this out. Okay, so we need to put some numbers on this chart first. So I'm going to leave the schematics here, but I'm going to fill in the numbers below. Okay, so we know that the mean was 30 slices. And we know that the standard deviation is 4. So we're going up by 4 as we go to the right here. So 30, 34, 38, 42. Okay, we're going down by 4 going left. So it's 26, and then 22, and then 18. Okay, so minus 4 going that way, plus 4 going that way. Okay, so now all we have to do is find the section that we're looking for. So in this case, we want what percent of pizzas have more than 26 slices of pepperoni. So we see we do have 26 here, which is helpful. So we know that it's right on this line, and then we want to know what's bigger. So this line and onwards, or in other words, if we were to take just a little highlighter here, we want this whole section. Okay, so we take all the numbers in that section. So in this case, that is 34, whoops, wrong marker, 34, 34, 13.5, and 2.35. And we just add them all up. In this case, that'll give us 83.85%, which means 83.85% of pizzas had more than 26 slices of pepperoni. Okay, so pretty simple once you've got all this down. What if the question was a little bit different? So let's say the question was instead, how many have more than 26 slices of pepperoni, assuming that we sold 200 pizzas? Okay, so how many? So all we do is you take your percent that we've already found right there, and we convert that. I'll just put in red. This is kind of our bonus question. We convert that into a decimal. In this case, that's 0.8385. Remember, that's just divide by 100. Okay, and then you take that decimal that you found, so 0.8385, and you multiply it by the number of, in this case, the number of pizzas, the number of items that you're looking at. And this should give us roughly how many in this set fit into that section. Okay, that'll give us 167.7. Now, does that mean that there's 0.7 of a pizza that fits in that section? No, but this is statistics. It is what is most likely in there. So likely, it's closer to 168 than 166, but unless we know exactly which pizzas you're dealing with on a particular day, we won't be able to give you a number. But over the average, this is the average number of pizzas that have more than 26 slices of pepperoni. Okay, so that is how to check to see if something is normally distributed. That is what normal distribution is, and that is how we use normal distribution curves to analyze a data set.